Okay. Hello to everyone. Welcome to this acoustic imaging webinar. We're going to be focusing today in food and beverage and manufacturing industries, and of course, like focusing on one of the main kind of benefits. So looking at the cost savings. My name is David Gambarte, and I work in business development in APAC. And I'm having here my colleague Abraham Martinez. You can say hi.
Hello everyone.
So Abraham is an expert in the camera uses. He's an expert as well in the technology itself. So he will be supporting to whereas I cannot get with my own know-how, and he will be of course like up to interrupt me anytime he thinks a good moment for it. I will suggest that for any coming questions or any inquiry, we will use the Q&A chat. We will go through it. We will be replying to the questions. And when we finish the slides, the presentation, we will actually reply to those that are not replied. And so we try to cover all the questions raised during this webinar. So basically, this is the agenda for today. We will really briefly talk about SI-124 and the SI-2. So SI-124 LD Plus camera focus for leak detection, and the SI-2, which is our latest version of acoustic camera, our most kind of advanced model. Then we will go through the cost of hidden leaks, like talking a little bit about what leaks represent in facilities. Why using acoustic imaging for leak detection? I hope that we already have a clear idea of why, but we will talk about it a little bit. Then application stories, some kind of experiences that we had, some examples that you of course might be already familiar with, but we will go through them. Benefit of acoustic cameras in general, talking a little bit about the ROI, the return of investment. So how we approach the calculations, which is pretty straightforward, but it's worth it to check. And then a little bit through sustainability, and then a Q&A round. I again apologize for being late with this, and I will now start with the presentation. So in this webinar, we're going to be focusing in the use of two solutions. One is the one you find in the left side of the screen is the SI-LD, the SI-2 LD, or like it could be also the SI-2, which is like having a broader use with also partial discharge. And then the SI-124 LD Plus, which is our previous model for leak detection. Both are perfectly operational for leak detection. Of course, the SI-2 has improved capabilities, and it has like some features that the SI-124 LD Plus doesn't have. But they are kind of both cameras interesting and very, very powerful tools to perform the leak detection and look at the cost saving and the risk transmission. So as you can see here, we have the SI-2 having a broader frequency band. So for frequency detection in between 2000 and 130 kilohertz, which is basically aiming to cover also mechanical fault detections in the new use of the camera, because we have a new feature on Make Mode. The SI-124 is actually, as we said before, is not going so high into 130, so it's going from 2000 to 65,000, but it's actually a perfectly operational camera for leak detection. So there is a difference in between the range, but I will actually believe myself. I want to think that both are actually perfectly operational in a kind of leak detection kind of situations, because 100 meters of anything over 50 meters, I will say, is not mostly needed by anyone for leak detection. So SI-2 is actually having a lower detection threshold. So can you return to that slide?
Yeah.
A lower detection threshold. So it's more sensible, let's say. So we have in both automatic frequency filtering and auto distance up to 5 meters. So that's very important to know. So the auto distance, so the automatic distance calculation done by the camera is up to 5 meters. Over 5 meters, users need to select the distance estimated, or maybe use a laser for kind of distance calculation. The big difference in between both cameras, as we consider a big improvement, is that the SI2 has a list of gases that are included in our calculations. So to be clear with this, SI124 LD Plus is a camera is already being used by many customers all over the world for gas detection, gas leak detection, pressurized gases. But SI2 have as a difference, as an improvement, and some name gases that we actually give calculations on a screen. So basically it means that when you are finding for example, hydrogen or CO2 leak, you will have on a screen the leak size, estimated leak size, and the leak cost, which is something that for SI124 we only have for compressor leaks. I saw that there was a question, we can go through it later, but there was a question about other gases. We will be extending our gas list along the time, so we are working already in adding new gases to our gas selection mode. In any case, if the gas is not included in this list, the recommendation is to put automatic filtering. Look for a gas that has a similar kind of density, because the density is fundamental for the gas leak size calculation, and basically look for the gas leaks, because the camera will anyway find the gas leaks. They will feel like a pressurized leaks findable with acoustic cameras. So we don't say no to other gases, like for example oxygen that was mentioned. So you can find oxygen leaks. Actually, we already have customers that are using the camera for oxygen leaks detection. So in addition to this, we already have, let's say that we have two main legs of our product portfolio. So one is the hardware with the cameras, the acoustic cameras, but not only that, we also have an acoustic viewer that actually allow customers to monitor in a hierarchic manner different departments in the same factory, different factories in the same organization. They can actually follow up the fleet management, how the cameras are moved from one place or one department to another, one factory in one city to another city. The snapshots, so basically the inspection results, the inspections outcomes, will be actually located in those, for example, we are talking about here, we have here this EMEA and LATAM, but let's say there will be, if you have, like, for example, Shanghai, Beijing, and Singapore, for example, you will have actually the snapshots found in the factory from Singapore under the Singapore kind of box, and then management will be able to follow up how the cameras have been used in the different locations, following the different protocols of in this case, leak detection. We also have a leak fixing feature, which actually allows any kind of inspection professionals or managers to follow up how much time is taking from leak finding to leak fixing. So that means that you basically could establish, for example, in a factory that, hey, we are doing inspections every second week. By weekly basis, we're doing one inspection, and all those leaks need to be fixed. The phone leaks need to be fixed, for example, within 2 days, 3 days. And then you can follow up how those leaks are fixed, how much time is taken in every one of the production plants or production units. They are actually how much time is taken to fix those leaks found in there. So it's a very powerful tool to implement protocols and to actually calculate the cost saving by just downloading all the data into Excel and making your own calculations on, depending on the company policies, you will be able to calculate however you need. So just as an addition, we also have this data connection API possibility now that is actually available in the cloud. And now for those organizations that want to basically be able to connect this data with their own reporting systems, they will be able to do it. Of course, we need to follow a process, a certain protocol to check if the company is able to do it, if they have the resources to do it, of course, because they need to have an IT, an IT team for it, and the know-how. But we will be supporting to a certain extent along the way. And we are already working in this regard with some customers. So we are open to that in those customers where it justifies to have the data connection API. Yeah, we are now going into the topic. So what do we do with acoustic cameras? Saving energy costs, ensuring product quality and safety naturally in food and beverage, as we are focusing in this industry, improving the efficiency, not only for food and beverage, but also for manufacturing, of course, and fighting hidden problems. So that's actually not a least thing. It's not a minor problem. I mean, often those hidden problems are the ones that are representing a big issue when they are found, because they are an accident or a big breakup that might actually represent, for example, a cutting production. So if we, yeah, thank you, Ron. So yeah, in food and beverage, I mean, it's not rocket science. So you might find that even small leaks represent major issues in food and beverage. So they can represent a source of contamination for products, which is actually a big problem in food and beverage, or might represent a big problem, of course, with customers and with authorities. It reduces the operational efficiency naturally, unplanned downtimes, as I mentioned before, increased energy cost. I don't think I need to read everything, but yes, reputational implication is maybe the last one in the list, and is maybe not the most important one thinking about customers, but it is fundamental, of course. So there are so many problems that might be created by even small leaks. So in manufacturing, we are talking about somehow similar or aligned parallel problems, but yes, energy cost is, as you know, it's a big thing. It's a big topic now in the market. So it's very important to tackle the extra energy use for compressor production. And our cameras are an excellent tool for that. So of course, we talk about also reduced operational efficiency and plant downtimes, of course, again, risk, loss of costly specialty gases. Of course, gases are an expensive asset, and the risk, especially with gases, are big when we have like unexpected leaks. And the product quality, for example, let's put a very basic example with compressor. The quality of some specific papers, especially in low grammage papers, when you have issues in the production machines with the compressor, might actually be having big deviations, and that in some specific papers is a big problem for customers. So basically, even compressor leaks might represent quality issues. Yeah. Now, next slide. Well, regulatory and compliance, of course. Yeah. Well, talking about the cost, of course, this is about air leaks. When we are talking about compressor leaks, it depends so much on the conditions, of course. But the leaks are representing a big loss. So basically, it's estimated that between 25 and 30% of the leaks of compressor are actually hidden, so they are not known, and they actually represent a big energy cost, especially in those industries where they are using a massive amount of compressor. So we are talking about the direct cost of it. We are talking about the replacement of equipment because of the overperformance of the equipment required, and we are talking about extra maintenance cost naturally. I think this is a very well-known slide. We talk about acoustic imaging. Of course, this is a tool that can be perfectly used in combination with other technologies. We need to understand that we are not actually, I would say, even competing with anyone. We are just using or having a technology that can be used with many other technologies in order to have the best outcome possible for customers. So yes, in audible sound, in ultrasound frequency can actually be a very early sign of issues, and this is basically the main essence of this slide. Yes, now we're going into a food and beverage application history. As you can imagine, like in 24/7 operations, when we're talking about compressor leaks, we are talking about performance of pneumatic tools and equipment lead to unplanned downtimes, of course. When for example, CO2, the carbonation process is needed for soft drinks, those leaks may represent a big cost. And the cameras are actually an excellent tool to find those specific leaks and fixing them and avoid the cost, of course. So an acoustic camera identifies even very small leaks promptly, improving the system's efficiency, reducing operation costs, and ensuring product quality. So those things are valid for food and beverage. There is another kind of, let's say, use line, which is like preventing contamination due to vacuum leaks. Vacuum leaks represent a big issue in many industries, also in food and beverage, and allow contaminations to penetrate the products by allowing air contaminants to enter the packaging, leading to spoilage, quality issues, and even health risk for consumers. So we were mentioning this before. So vacuum leaks represent a big issue in industries, and our cameras are actually a really easy, direct way of finding those leaks in the different production and quality processes. An acoustic camera locates hidden vacuum leaks by capturing the emissions generated by the air entering the vacuum. Naturally, it's kind of a counter use of the camera, but we have already a number of customers using the camera for vacuum leak detection, and it's a very powerful tool for it. Well, now we're jumping into manufacturing, which is the other topic of this webinar. And as you can imagine, leak can disrupt the functionality of the manufacturing equipment, leading to impaired product quality. As we mentioned before, material flows increase scrap rates and even contamination, naturally. So when we're talking about leaks, we're also talking about the operator's safety, including the release of harmful contaminants, noise pollution, and potential hazardous accidents. So leak detection is not just about quality or cost, it's also about the health of the workers, of the professionals that are in your facilities. So, but of course, costs represent a big kind of, let's say, like a big asset, cost reduction. So manufacturing facilities are filled with equipment prone of compressor leaks. On average, leakage rate is, well, we mentioned this before, 25–30%, but in some cases it can be as high as 80%. I mean, it's coming to my mind now, what kind of rate of leaks do they have, for example, in some wood processing industry where they use a massive amount of compressor leaks. Sorry, a massive amount of compressor for moving the wood from one place to another. And then they actually didn't care so much for many years about the about the leaks themselves, but now they represent a big cost, and they actually by just looking at those and having implemented on place processes for leak detection and fixing, they can save a really big amount of money, a substantial amount of money that might actually be, for example, down to be invested in other fields that are beneficial for the organization. So of course, hidden air leaks, gas leaks lead to additional costs and plant downtime and even potential safety hazards, as we mentioned before. And they can also cause substantial financial losses on costly specialty gases, which are commonly used in many production processes across industry. That's something we already mentioned, and we are all aware. Of it. So this is, in brief, benefits of using an acoustic camera for leak detection in manufacturing: save time, energy, and cost by locating hidden compressor leaks, increases operational efficiency, scans large areas quickly, and I would like to stop here. So the cameras are extremely easy to use. In our experience, I've been myself to many production facilities, but all my colleagues will actually support this. You just go visit a potential customer, get the camera, show the camera, you give the camera to them in their hands. They can start using the camera immediately and they will start finding leaks immediately. The cameras are extremely easy to use. You just go inspect the area you want to inspect. It will spot where there's a leak. You will be able to take a snapshot and you get it. You already have the information you need to make a decision on that specific leak. So we're talking about very easy to use cameras, and that's actually one of our flagships. Requiring minimal training, which is totally aligned with what I just said. Allows inspections to be carried without any halting operation. So you just go on production facilities without any interruption, and you just go and find where you need to make the fixing. So yes, can you go back to that? Yeah.
Oh, sorry.
Yeah, go back to that. Sorry. Yeah, and provides real-time results and actionable data for maintenance and repair plans through machine learning-driven analytics. Of course, our data is not coming from magic. So we have been gathering a lot of information. We have really powerful algorithms to calculate exactly where the leaks are, to filter all the non-relevant noise around, and to give you exactly the information you need. So you don't need to do anything else by just spotting the camera in the place you need to inspect. And the real-time results are fundamental to make quick decisions where you find, in this case, leaks that need a quick action. And then, of course, with the actionable data, you will be able to go into the cloud and print or download the reports and find out what you need to do and in what time, what kind of the timing for the fixings and so on. So you will be able to react quickly on those leaks that require it, and you will be able to make actually plan and fixing, a fixing planning on those leaks that can actually be fixed a bit later. Yeah, this is just an example of a return of investment in a large facility. So they are normally noisy industrial facilities where they present a challenge to the accuracy and efficiency of leak detection methods. There are so many leak detection methods in the market. Yes, as an example, a recent inspection with the SI 124LD Plus, which is the previous model that we still have in the market, and it's a pretty workable model for leak detection. We were able to identify 155 leaks in just 6 hours. This is, of course, a proper inspection, as you can imagine, where many companies, for example, outsource the services. But by just having the camera, you can do it yourself. You just can go and use one of your maintenance professionals to do the inspection themselves, and you will save a lot of money. In this case, we are talking about an estimated ROI of 4-6 months with 2 inspection rounds, which is a very powerful one. Naturally, when we are talking about other gases or compressor, not compressor, but other gases, we are talking about something very powerful in terms of return of investment. During a recent inspection, as you can see here, using also the SI-124LD Plus, even though we already have the SI2 in the market now, so we will soon have examples of the SI2. Within just 10 minutes, we found leaks, well, 5 leaks actually, that resulted in annual savings of approximately 12,000 euros, which is around $13,000. So the estimated return of investment in this case is just 2 months. Why this? Because gases, as we said, they are really expensive assets and really sensitive ones. So it's really, really important to be able to find the leaks quickly and fix them. Naturally, there are also other side kind of benefits of using acoustic cameras. So we are reducing the CO2 emissions, identifying and repairing leaks promptly helps minimize energy consumption and carbon emissions, contributed to a greener manufacturing process and aligning with sustainability goals. We actually calculate the CO2 emissions of the leaks now in our cloud service. So when you actually have your leak reports, you will be able to also have the CO2, the estimated CO2 saved by those leaks when you are fixing them. Improving energy efficiency. Well, timely leak detection ensures that energy is not wasted on compensating for air leak, improving responsible resource management and reducing the environmental impact of the operations. So it's not only about compliance, but it's also about environmental impact itself. So what is your position in our in this global issue that we have now with the environment? So SI2 and SI-124LD Plus benchmark. So we have a high-performing acoustic camera. Naturally, both of them are high-performing, but SI2 is a bit more efficient, better improved camera solution. But both are, as I said, both of them are perfectly operational. That save time, cost, and energy. Safe and easy to use only with one hand. And this is not a minor thing. So you have a camera that you can actually be using only with one hand. So basically, for safety reasons, you will be having the other hand to, for example, grab any kind of like a security system. So, or for example, if you are falling down and you have you're tripping, you will be able to use the second hand for protecting yourself. So it's very important that the camera is one-handed for us, and it requires minimal training. Provide real-time leak size and cost analysis on device, and of course our smart AI-driven functionalities deliver seamless user experience. Actually, our functionalities, our AI-driven calculations and algorithms are not just about the calculations itself, but also about the simplification of the process of the leak finding. So we have cameras that will allow users to find the leaks without, as I said before, without any training, with just taking some time to go around and do the inspections, and they will find the leaks quickly without any kind of thorough process. So the camera is automated for easy workflow. So the smart AI-driven functionalities ensure the seamless user experience and speed up inspection by further simplifying tool operation. We already mentioned this. We have auto filtering, which is a very powerful tool for us. So users don't need to be working with them or playing with the frequency up and down and trying to find what is the best filter frequency level. So the camera will select actually best frequency for the specific leak that is found, and the user will have the needed information on the screen. So no need of any kind of like cautious work or very thorough work with filtering or with frequency selection. And the auto distance, as I mentioned, the auto distance is in quite a lot the life of users, because up to 5 meters, which is a very normal distance for leak detection in many industries, will make them to just go screen with the camera and find the leaks without any need of actually having any kind of distance estimation and so on. So find fast, fix fast. Yes, as I said, with the problematic leaks are located quickly and clearly in the user display. As you can see here in the screen, each sound source is indicated with a single color marked according to the intensity of the sound. So green, orange, especially green, are yellowish, are smaller leaks, orange or red are bigger leaks. So it's not actually, let's say, down to any kind of scientific filter, but we basically give an estimation with this color to allow the customers to make a quick decision on the leaks. The wide field of view allows large areas to be scanned quickly. So basically, you could be walking a few meters, about like 4 or 5 meters from the distance you're expecting, and you will be able to find and to make a really quick work on those large facilities where you need to go. You need to be like using auto tag for it. Multi-source mode, which is actually our default recommended mode, will allow you to find, for example, 2 or 3 leaks if they are in the same area, so you are not missing any single leak because one is kind of disturbing the other ones. So you start with multi-mode and you will be able to find, for example, if there are 2 leaks, and then you focus in one and you get the calculations of the screen for it. On-device leak quantification for real-time decision support. Yes, as I mentioned, we will, as you can see here in the screen, we will show you the decibels, the leak estimation, the leak size estimation. In this case, it's in liters per minute, but you can actually set your own units as you wish. And then the cost estimation. Naturally, the cost estimation is coming from some setup that you need to introduce into the camera. For example, we are talking about compressor. You will need to introduce what is the price of the kilowatts per hour, for example, of the production of the compressor. If we are talking about gases, you will need to be introducing in the camera what is the gas cost for you, the asset cost. So basically, you will have the yearly cost of the specific leaks, and as I said before, you will be able to make quick decisions of those that require quick action. The camera, our reporting is ISO 50001 compatible. So the reports are actually making you an easy kind of compliance work. After you have done your inspections, you need to be reporting to authorities. You will be able to, to do it without any kind of big effort of adapting data and reporting. So now we come to the Q&A. I see that my colleague Abraham has been replying very quickly all the questions and has been tackling all of them. You have here the product page and SI2 introduction video and SI2 PD training video. We will share this with you, so you will be able to, with all the attendants, you will be able to actually find this in the presentation, so you will be able to go to these product pages later on if you wish. And we are, of course, open to any questions that we know Abraham is taking care of. I will also open my own Q&A, and I will try to help Abraham with this replies.
So we have on the chat questions. Sorry, lost. How do SI2 recognize those different gases? Those AI tells the wave shape difference between those gas turbulence.
Yeah.
Well,
do you want to take it?
Yeah. Well, basically, the user needs to select the type of gas, and based on that selection, the camera will store this value and retrieve the information.
Yeah, we expect the user to, of course, to know the gas that is in the pipe or in the component where they are finding the leak. So they just need to introduce the gas type or the gas name, and then the camera will automatically do the calculations afterwards.
Then another question is, do we need to have inputs to the detected leak, such as distance, temperature, or humidity?
I will say that it's recommended to check the temperature before you start in the inspection and the humidity level. Both might be having some impact on the leak size calculation, so it might be relevant to do it like in the morning or before you start in inspection to check it. In many cases, you will not need to modify anything because the temperature might be kind of similar along a certain time, but just check it. And it's a standard recommendation for us. So just once every sometime if you see that there is a change, you need to, of course, modify, for example, the humidity level. But yes, it's recommended too.
Yep. And also the distance is detected up to 5 meters. And after 5 meters, the user needs to input the distance. Another question is, when using the multi-source leak default, can we still find high intensity leaks? Yes, currently the multi-source, it shows how many, let's say, leaks or sources you have on the field of view of the camera. So how many leaks you see on the camera. So it's not basically related on the high intensity of the leaks. However, the camera, as we see, it displays some metrics that you can see the SPL level, for example, or the leak cost or the leak estimation. And those values are corresponded to the highest leak, for example, or the highest PD, let's say, the highest metrics. So there is two different concepts. So the multi-source, yes, it shows many different sources. And tied to that, the information displayed on the camera, it belongs to the highest or the highest source, we can say. Do you have anything to comment on this question?
No, okay. No.
Another question: does the SI2 have a sound range for the marker if it shows green, orange, or red? Yes, on the device, it has some kind of limits. But when you transfer those snapshots to the cloud, you can define how the intensity is. So in that sense, it's very flexible to use. So any kind of, for example, maintenance group or teams, they can select how, for example, a leak is a low leak, or it's a moderate leak, or it's a high leak. So this can be also customized by the user.
Mechanical mode is something that we have been thinking whether we include it or not. We are glad to do a mechanical mode webinar, and it will be really interesting also to discuss with you. I think the most interesting part of this webinar is also discussing with you. We could even consider to open the mic and discuss. So it was like we have to decide, but yeah. We should do a mechanical mode presentation definitely, and we will maybe put one in the calendar soon. So we will check soon. And thank you very much.
Thank you very much. Thanks everyone. Have a good day.
Thank you. Have a good day, everyone.